If you or a family member you knew was affected by a genetic disorder, such as Alzheimer's or sickle cell, there normally wouldn't be anything to do other than to try treatments that would lessen the symptoms. But what if we told you there could be a way to permanently cure these disorders? Would you be interested? Enter CRISPR-Cas9. CRISPR-Cas9 stands for Clustered Regularly Interspaced Short Palindromic Repeats and Associated Protein 9, and is the most versatile genomic engineering tool created to date. Here's how it works. The CRISPR-Cas9 acts as a pair of molecular scissors. It is able to cut pieces of a genome out. It is guided to the target genome piece by a pre-selected RNA molecule. The cutout piece can then be replaced with a desired genome segment. There are over 6,000 disorders caused by genetics. Some of those include Down syndrome and sickle cell disease. 1 in about 17 people are affected by a genetic disorder in one form or another, and there are only treatment plans for about 600 of those 6,000 disorders right now. The treatment plans look different depending on the disorder. Many genetic disorders are the result of a gene change that is present in almost every cell in the body. As a result, most cannot at this time be cured. Instead, treatment and management strategies are used to improve or treat symptoms of the disorder. As an example, a genetic disorder that affects the heart might be treated through surgery in order to repair the defects. Sometimes, heart transplants are used. These steps are taken to try and reduce the negative symptoms that the person is experiencing, but it does not cure the disorder. Some have thought that using CRISPR-Cas9 could lead to actual cures for genetic disorders, and they were actually right. Sickle cell is a genetic disorder which causes defective hemoglobin to be produced. This defective hemoglobin doesn't carry the oxygen properly and deforms the blood cells, making them sickle-shaped, hard, and sticky. This makes it easy to get stuck inside of blood vessels. Victoria Gray was diagnosed with sickle cell disease as an infant. Most patients would need a blood transfusion, but that would require a donor whose blood matched. Victoria was treated using a method that involved CRISPR. It goes like this. The treatment revolves around fetal hemoglobin. Fetal hemoglobin is produced by all fetuses in the womb. However, after birth, production of hemoglobin stops, and normal hemoglobin is instead produced. Because patients who experience sickle cell do not produce normal hemoglobin, the idea is to have their cells once again produce fetal hemoglobin. First, bone marrow cells are extracted from the patient's blood. Then CRISPR is used to edit a gene in the cells, telling them to start producing fetal hemoglobin. The patients then undergo chemotherapy in order to wipe out the existing cells carrying the sickle cell defect. Then they receive billions of their own cells that have now been edited with CRISPR back into their body. This approach provides a treatment plan for all patients, including those who aren't able to find a matched donor. In 2020, Victoria was once again interviewed and checked on. The gene-edited cells had persisted the whole year. It was a promising indication that the approach had permanently altered her DNA and thus cured her. Now that we have seen that CRISPR-Cas9 can effectively treat and cure some genetic disorders, we will look at the ethics of using CRISPR based on the 4 pillars of ethics. They are beneficence, non-maleficence, autonomy, and justice. Beneficence is the idea of doing good, while non-maleficence is the idea of doing no harm. Autonomy is the idea of being able to govern oneself. Finally, justice is the idea of giving each person what they deserve or what they are due. As seen by the results of Victoria's treatment, good can be done, meaning that the use of CRISPR does follow the pillar of beneficence. However, CRISPR is also a new technology. Because it is new, there are still risks and unknowns. This could lead to potential harm as we try to learn more about CRISPR and how we could further use it. Doctors and scientists could make mistakes, which would lead to more harm to the patient than was originally being experienced. That would go against non-maleficence. As for autonomy, Victoria knew what she was agreeing to and was able to choose for herself, so we don't see any problems there. Finally, there's justice. Victoria's treatment cost around $2.2 million for the one-time treatment, and because CRISPR is so new and expensive, insurance companies are more likely to deny paying for it, using words such as experimental and not medically necessary to justify this. This makes this treatment not open to everyone, which goes against the pillar of justice. So now that we've looked at how CRISPR works, how it's been used so far, and looked at how it stands with the 4 pillars, there's just one question left. Are you still interested in giving CRISPR-Cas9 a chance?